Welcome to Study Loop.
Now we'll work on problem 30 from chapter 1. Here we're asked to go back to question 4 and say what is the kinetic energy and velocity of the silver sphere in problem 1.4 at the moment it hits the ground. And we want to assume the energy is conserved during the fall and that 100% of the initial potential energy is converted to kinetic energy by the time impact occurs. So if we look back at problem 4, we'll see the potential energy, which we have is going to be equal to the mass of the silver sphere times the acceleration of gravity times the height, 2.2 meters. And this gave us 44.4 joules. So that's the potential energy. Now to find out the kinetic energy, we look at the problem and it tells us to assume that energy is conserved and 100% of kinetic energy has 100% of potential energy has been converted to kinetic energy. So the kinetic energy at the moment it hits the ground will be all of the potential energy because there is no more height. So it's 44.4 joules, which is the first part of the question. The first part is what is the kinetic energy? The second part is what is the velocity? Now we know kinetic energy is equal to half mass volume velocity squared. So we can rearrange this to get the velocity by itself. We get velocity is equal to the square root of 2 times kinetic energy over the mass, which is equal to 2 times 44.4 joules and divided by 2.06 kilograms. And if we do this calculation here, we get 6.6 meters per second as our